Hi all, here are the notes for 6.7. This is the last section we do in this course. And from here, the next thing is final exam. So this is solving equations using the zero product rule. So basically what happens in here is we're going to take all the things we've been working on and combine them into solving equations. The first thing to know is that when we are putting things in standard form, this is it. It is that same quadratic form that we've been using all the time, where it's descending by greatest exponent at the front, ax squared plus bx plus c. But then what we need to have is the opposite side equal to 0. That's the way this has to work. Okay? The zero product rule is this. It's based on this idea that we get to do the work in solving equations that we do from here. If a times b equals 0, then a equals 0 or b equals 0. So if one of them equals 0, one or both also equals 0, which means that we can break up a product and set the product, both parts, both factors equal to 0, and that's important. So when you see something like this, to solve this equation by using the zero product rule, what happens is I don't have to multiply through and FOIL, which would be miserable. What I get to do is, because you can think of this as A and B, and I could set A equals 0, B equals 0, because A times B equals 0. So I'm going to set, I'm just going to write A, no, I don't want to do that. I'm going to set x minus 4 equal to 0, and then I'm going to set the other factor, x plus 3 equal to 0, and I'm going to solve both of them. So on the left-hand side, x is equal to 4, and on the right-hand side, x is equal to -3, and that is it. Do not let Alex mess with you here. You're going to look at this, you're going to try to multiply through, and then you're going to factor again and get right back here. So think of this as a, x plus 1 is a, x minus 8 is b. I could set a equal to 0, x plus 1 equals 0, and b is x minus 8 equals 0. And then I'm just going to solve the way I solve one-step equations. So x is 1, sorry, -1, or x is 8. And in quadratics, where there's a square, we generally have two solutions. Okay, so you get the idea of what's going on here. You can solve these. Do the same thing. In the first one, x is going to be -8 and 1/4, or -1/4. And in the second one, x is going to be 5/4 and -6. So far, so good. All right, this looks trickier, but it's not. These are still products, and this might as well be in parentheses. So I'm going to treat it exactly the same way. This is A, this is B. So I get x equal to 0, and I get 3x minus 7 equal to 0. This one is just x equal to 0. I'm going to add 7. I get 3x equals 7 divided by 3. X is 7/3. Remember, 0 is a valid answer to something. Like if you ask me how many cupcakes I have right now, I have 0. That's the truth. On this side, same thing. X is 0, but you can't ignore that x. It's got to be accounted for. Or x is equal to, or 4x plus 9 equals 0. And I'm just going to solve 4x plus 9 for x. So 4x equals -9 divided by 4. So x over here is 0 or 9/4. That's it. No, -9/4. I lied. All right. Moving right along. So when we do these 3 steps, write the equation in the form ax squared plus bx plus c. Factor it completely. It's not always going to come to you factored. And then use the zero product rule. Set each factor equal to 0 and solve the resulting equations. You can check your answer for x by substituting it into the original equation and making sure it works. So let's try all that. So first, my first problem here is that I need this to be x squared, ax squared plus bx plus c equals 0. And that is not what I have here. So I'm going to subtract 5 from both sides. So I'm going to get 2x squared minus 9x minus 5 equals 0. And now I need to factor, so I need to stop for a second and think. Can I just factor normally? No, because there's a 2 in front of x squared. It's not anything special like a difference of squares or differential cubes, so I'm going to use the AC test. So I have two numbers that multiply to 10, negative 10, and two numbers that add to negative 9. Well, that's going to be negative 10 and positive 1. So I'm going to rewrite the b term, 2x squared minus 10x minus x minus 5 equals 0. And then I'm going to, I need to find my cursor here so I can scroll down. Then I'm going to factor by grouping. I'm going to change colors. So out of the first set, I'm going to take 2x, and I'll leave you x plus 5. No, x minus 5. X minus 5. On the second one, I'm just going to take a 1, and that's going to be x minus 5 equals 0. So I'm going to pull the x minus 5 to the front, and then I've got 2x plus 1 equals 0. And now I use the zero product rule. So now I can do x minus 5 equals 0, 2x plus 1 equals 0, and solve for x. So I get x equals 5, and I get x equals negative half. And then if I want to check my answers, what I do is I take this answer 5 and put it in here where I see x. So I do 2 times 5 squared, 2 times 25 is 50, minus 9 times 5 is 45. That equals 5. So this answer works. That's how you check. You try the second one. Same exact process. Follow what you see on the left to help you figure out how to do the right. So it's going to end up being 2y squared plus 19y plus 24 equals 0. I want two numbers that multiply to 20, 48, and add to 19. They are going to be 16 and 3. So I'm going to make 2y squared plus 3y plus 16y plus 24. Whoop, not 230. And then I'm going to group. I'm going to take 2y, I'm going to take y out of the first one and get 2y plus 3. And on the second one, I'm going to take 8 and get 2y plus 3. Common term to the front, which is 2y plus 3. Collect what's left, which is y plus 8. And then use the zero factor property. 2y plus 3 equals 0, and y plus 8 equals 0. So the first one is going to be negative 3 over 2 equals y. The other one is going to be negative 8 equals y. All right, not terrible. So these, I'm going to do a couple more. They're going to look kind of funny, not the end of the world. So this one, it's already set up the way I want. So really, when there's not a third term, you can't do the regular factoring. It's not a perfect square or difference of squares. So I want to look for common terms, and there is one. I can pull out a 4x. So that leaves me with x plus 6. And now at this point, I have two products, right? Just like I did before. So I can do 4x equals 0, x plus 6 equals 0. Divide this one by 4, x is 0. Minus 6, so I get x is 0 and x is negative 6. For the other one, the second one, I have to get it in the right form first. If it's not equal to 0, none of this works. So minus 45. So I get 5s squared minus 45. Well, a common equals 0. Common term would be 5. So I'm going to get s squared minus 9 equals 0. And then I have to think about that. Well, that's a difference of squares. So I get 5, s minus 3, s plus 3 equals 0. And then the thing I have to keep in mind is it doesn't matter how many products there are. We set 5 equal to 0, s minus 3 equals 0, and s plus 3 equals 0. Here's the thing, 5 equals 0 doesn't matter because it's not true. I'm going to add 3 to both sides there, and s equals positive 3, and then I'm going to get s equals negative 3. We lived. We survived. Hallelujah. All right. So now this one's more complicated, obviously. Like there's more moving parts here. So we just have to think for a second. First we have to distribute. So I get 25x squared plus 10x equals 10x plus 9. Well, I know my first job is to get it in standard form, so I'm going to move the 10x over. Get 25x squared. 10x minus 10x just disappears, equals 9. I'm going to minus the 9 to the other side. So I'm going to get 25x squared minus 9 equals 0. Well, that seems special, doesn't it? It's a difference of squares. So I'm going to do 5x minus 3, 5x plus 3 equals 0. And then I'm going to set them both equal to 0 like I've been doing. 5x minus 3 equals 0. 5x plus 3 equals 0. This side is going to be positive 3/5 equals x. The other one is going to be negative 3/5 equals x. All right, we lived through. Try the next one. Standard form first. Factor. Work through. Like ask yourself all the questions. You can do this. So distribute. 4z squared plus 12 equals 4z plus 5. Well, I'm going to move the 4z over to the other side and move the 5. So 4z squared minus 4z, 12 minus 5 is positive 7, 0. All right, well, nothing special here. I guess I have to use the AC test. Oh, wait. That was a 4z. This should be a 12z. That's where I messed up. Maybe something was wrong. 4z minus 12z. All right, let's try that. 4z squared. 12z minus 4z is 8z minus 5 equals 0. Okay. So now I need to use the AC test. So I need two numbers that multiply and make negative 20, add to make 8. Let's see, the negative 10 and 2. So I'm going to rewrite the 8z as negative, let's see, 2z and negative 10z. Okay, and groups. Whenever you see four terms, your brain says group. But 2z, out of the first one, leave me with 2z plus 1. The second one, I'm going to take out negative 5. It's going to leave me with 2z plus 1. Pull the common term to the front, 2z plus 1. And then 2z minus 5. Set them equal to 0. 2z plus 1 equals 0. 2z minus 5 equals 0. First one's going to be negative 1/2. And the second one is going to be 5/2. And the more of these you do, the more times you go through them, try them again and again and again, the better this all will get. All right, in this case, it says solve the equation. Well, don't sit here and multiply these all out. Remember, zero product rule. We can do this as many times as we need to. So I can set them each to 0. Y plus 3 equals 0. Y minus 5 equals 0. 2y plus 7 equals 0. And then you're just going to solve E1. Negative 6 equals 0 is not true. In this case, y is going to be negative 3. This is going to be y equals 5. And this is going to be y equals negative 7/2. You get the idea. You can do the bottom one. We're going to get p is equal to 4, negative 7, and 9/2. All right, so solve this one. This one is weird, right? Something different about this. Well, let's talk about what that is. So what's happening here is I can factor this by grouping. It's two groups, right? Four terms should always say two groups. So I'm going to take out w squared out of the first group. And I'm left with w plus 5. And out of the second group, I'm going to take out negative 9 and get w plus 5 equals 0. And then I'm going to get w plus 5 equals 0. well, not yet, hold on. W squared minus 9 equals, that whole thing equals 0. Now I need to see the difference of squares there. So it's going to be W plus 5, W minus 3, W plus 3. All of that equals 0. And you're going to set each one equal to 0. So what's going to happen is I'm going to get W is negative 5, 3, and negative 3. Down in the bottom, the same thing happens. X is going to be equal to 2, negative 2, and 3. So that is the end of the notes. Come on into the discussion if you need help. I will see you there.